The last thing I want to go over for compound interest is something called effective rate. Now, the effective rate is sometimes referred to as APY or annual percentage yield. And the effective rate is a way we can compare accounts that are slightly different against each other to see which one is a better investment. In particular, effective rate is the percentage earned by an investment over a single year. So we're looking at just what percent we have earned in interest over a single year, 1 year. Now, what's helpful about that is that different investments may have slightly different annual percentage rates and slightly different compounding periods. Now, if they all had the same interest rate but different compounding periods, we'd know the more compoundings, we'd earn more money. If they have the same compounding periods but different interest rates, we know the higher interest rate gives us more money. But sometimes they will have slightly different interest rates and slightly different compounding periods. And the effective rate, because it narrows everything down to exactly the percent you earn in interest for a single year, is a way to put everything into a single number for that account and compare them. And let's look at an example of that. So I've got two accounts here. Account A earns 8.75% compounded weekly. So a lot of compoundings a year. That's 52 weeks in a year. So N is equal to 52. 52 times you earn interest a year. So that's a lot. Account B earns a slightly higher interest rate, 8.79%, but it's only compounded semi-annually, so that would be N equals 2. So less compoundings, but a higher interest rate. Is that going to be better, the higher interest rate, or is more compoundings going to be better with a slightly lower interest rate? What we can do to compare is calculate the effective rate. Now, effective rate is basically going to be the interest you earn during a single year in 1 year divided by the amount you started with. To actually work that out, we need to figure out how much interest we earn in a year. Now, in these two problems, I haven't said what we start with. It turns out it doesn't matter how much money we start with. So let's choose a nice, easy number to work with. Let's say we invest $100 for 1 year. All right, so if I were to calculate the interest, I would have to start by calculating the amount we would have after 1 year. So that would be $100 times 1 plus 0.0875, the interest rate, divided by 52, because remember my compoundings here is weekly, so 52 times during the year, raised to the exponent, which is N times T. Now that's 52 times, we're only going 1 year, so that would be 52 times 1, or just 52. So my A, when I calculate it out with a scientific calculator, 100 times parentheses 1 plus 0.0875 divided by 52 raised to the 52th power would come out to be $109.14. The interest for that would simply be to take off that $100. So it would be the amount minus what we started with, the principal. So 109.14 minus 100 means that I actually earned $9.14 in interest. The effective rate is to take that interest and divide it by how much we started with. We started with $100. So we divide out the 100, and we do that. Dividing by 100 is really nice. It just moves the decimal place. We are going to get, I don't even have to round off, it's going to come out nicely. It would be 0.0914, or as a percent, 9.14%. This is what we call the effective rate, or basically our return for that investment over the single year. We're earning 9.1% for that 1 year in interest. If we look at it just as a single year, we've earned 9.14% on our investment. Notice that effective rate is slightly more than our annual percentage rate. That's because the effective rate takes into account the compoundings. Let's do the effective rate for account B. Again, let's use a general $100 that we invest for 1 year. A is equal to 100 times 1 plus, we have a slightly higher interest rate, 0.0879 for 8.79%, but we only have 2 compoundings per year, so we divide by 2 and then raise that to an exponent of 2 times 1, or just 2. When we calculate that, we get a total amount in the account after 1 year of $108.98. So the interest we've earned in 1 year is actually $108.98 minus 100, or simply $8.98. And you can tell already that is better, that's not as good rather, as what we did in account A. But we can calculate the effective rate by taking that amount we earned, $8.98, and dividing it by what we started with. And when we do that, we get 0.0898, or as a percentage, that would be 8.98%. So my effective rate on the second account is 8.98%, whereas on the first account, it was 9.14. So 9.14 is a better effective rate, earning rate, and therefore account A is a better investment.